This video shows the processing and interpretation of a formation test in Azurite. Clicking on the FT icon launches Azurite from the KAPPA-Workstation. A new document is created by clicking on the icon labeled blank. First, the main document options are defined. The next step is to create the first run in the document. An image of the tool schematic may be loaded here or at a later stage. Different tools and configurations are run depending on reservoir conditions and objectives of the operation. These are reflected in the data load in Azurite. It is possible to load several files in different formats in a single step. These can contain versus step data, for example, open hole logs, and versus time data such as pressures, temperature, and pumped volume at a station. In this example, 16 stations and one open hole log have been imported. Azurite will automatically identify the format of the file and the FT tool based on the mnemonics of each station. If the tool is not found in the Azurite catalog, the user can manually define it, which will then be added to the catalog. Any mnemonic not automatically recognized can be defined at this stage. Once defined, these will be stored for future use. At this stage of the load process, the user selects the reference channels of pressure and temperature, and volumes or rates to automatically identify tests for each station and rate them in terms of quality when calculating test parameters. The probe flow coefficient is used for the computation of the drawdown mobility. The user can define probe geometries from the built-in probe library. Automatic computations now run in the background as the data is imported for each station and rate to identify and categorize the test. These calculate key parameters, including reservoir pressure and drawdown mobility for tests categorized as a pre-test or mini DST. Criteria controlling these computations is defined in the document setting. On completion of the data import, the user is presented with the first-pass interpretation based on the defined criteria. The pressure and mobility for each station are displayed in this view for the tests with higher quality. We will revisit the Logs tab later. The user can now analyze the data and modify the results as required. Pressure change in time is displayed under the Stations tab, allowing for a more detailed look at a single station. The usual workflow may consist of observing the details of each stations, a quality check of the data, and recomputation of rates and selection of reservoir pressures and mobility. Total rate is calculated automatically based on the input data. If one or several rate channels are imported, the total rate, QTT, is the sum of each. If volumes are imported, then QTT is computed using the default setup. The setup can be accessed and edited as shown. The new setup may then be applied to other stations if needed. Automatic redefinition of tests can be performed as required. The Show One option focuses the zoom on the active test. Additionally, it is possible to edit PDD and PStop interactively. These parameters impact the quality of the test and the calculation of the reservoir pressure and drawdown mobility. Station results show a summary of each test identified at the station. These parameters reflect the values displayed in the test information, or they may be edited. For tests where the data is of sufficient quality, a pressure transit analysis can be carried out. Station 16 includes a test with the sampling period having a long drawdown and build-up stages. The test can be selected by a double click within the test limits. A PTA analysis can be initialized for the selected test. The fluid phase Test information and PVT information must be input to initialize the analysis. The analysis interface and models will be familiar to Sapphire users. Editing options are also available to process pressure and rate data. In this example, the rate and pressure data is synchronized at the start of the buildup. Upon extraction, the spherical derivative is also plotted on the log-log plot along with the usual Bourdais derivative with respect to the radial superposition function. Usually, the buildup of a formation test station displays a spherical and occasionally a radial flow period. The diagnostic lines help estimate model parameters which can be used to initialize the model. A nonlinear regression on parameters can be performed to improve the fit as necessary. Model results can be viewed for each analysis. The pressure and mobility results from the PTA can be compared to those from the automatic calculation carried out on the station and the station results. The user can decide which parameters are to be used on the pressure and mobility profile. The Well Results dialog shows a summary of all the stations loaded in the document. Under the Logs tab, the user can construct gradient lines using pressures from each station and identify contacts, if any. Open-hole logs and deviation surveys may be displayed together with station pressures and mobilities to help interpretation of the data. User tracks can be added, allowing for the combination of different logs. The browser gives access to the loaded data. Under the static paths, open-hole log data can be selected. As an example, density and neutron porosity logs may be combined to identify gas zones. The horizontal scale of any curve can be edited. Additionally, filled areas can be added to user tracks. This concludes this video on the Azurite Formation Test Analysis module.